Okay, you can start the presentation. You know, Noam used to say that the name is Yosi Shacham-Diamond with an A, the German pronunciation, and I'm going to talk about, in the next 10 minutes, I'm going to introduce to you to the world of biodefense. I'm from the Reichman University, from the Scojen Institute for Synthetic Biology, which is a new institute taking care of synthetic biology, and I hope in the next, great, I've saved 76 minutes to talk. You have to change it. Okay. I only prepared for 10 minutes. Now, just to start to introduce you, biodefense is a name. And in Hebrew, we say lehagen. In Hebrew, people always think that we are French. Totally different word. In other languages, people just use, in Japanese, people say only biodefense, or biodefenso. Chinese, they use the same kanji but different pronunciation. But the last line is, when we talk about biodefense, we also talk about what we call national security, because if a nation is secured, it's the defense itself. So I'm talking about biodefense, but you have to understand that there's another level which is called national security, which is also important for this issue. So there are two definitions to biodefense. One is defense against biological threats. However, we also look at the use of biological tools for unmet needs, which means not necessarily for detecting biological issues. We can use biology to detect explosives. We can use biology to detect people, presence, other features. So biodefense has a dual meaning, and I mean to them both. What's our message? Biodefense is a challenge. It's a complicated issue, and I'm going to talk to you a little bit about it. But the main rule is you always want to be one step ahead of the threat. So in order to do it, you need to look at what's available today and what will be available in the next 5 to 10 years. There was a quantum leap in the availability of capability of biological tools. The reason, biodefense was always an issue. But in the last 10, 20 years, there was a huge leap of progress in developing biological tools. The use of AI contributes significantly to that leap, the invention of technologies like CRISPR and other technologies, but it became more available. You can even do it yourself at home, things that people used to do in very expensive labs. So the problem statement, there are more threats, more tools, and what we call unknown unknowns, how to take care of it. So you need academic and government R&D centers, plus make sure that you do the technology transfer right. So the problem, the democratization of bioengineering and AI technologies, the threat of malicious use by non-state actors and amateurs, and the solution is detection networks, including biosensors, Internet of Things. You want to have a holistic solution detecting the threats, or open access platforms and do-it-yourself biolabs, empower underrepresented groups, and foster biotechnological innovation, which means everybody can do it. It's a threat. Solutions, more regulation, developing tagging techniques, barcoding. You want to make sure that there is some control on the source materials, on the development of them, to follow them, post-factum research. You need to know the threat. If you want to read more, take a look at this report by the DoD for 2023. Wonderful report. Talk about the biothreat environment, the naturally occurring biological threats, about the accidental biological threats, about the deliberate biological threats. There was even a nice book published in 2018. If you need to read more, you can come to me. I have a whole lot of library of publications. So this issue is on the open, and it's an issue, and the problem becomes more and more severe. The current key players in biodefense market is AI-powered biosurveillance, nanotechnology and biosensors, synthetic biology and genetic engineering, advanced vaccine platforms, and the contamination and sterilization technologies. I'm going to focus today only on synthetic biology. Now, this talk is about biodefense. We focus on biodefense, using biotechnologies to protect and defend, and using technologies to defend against hazardous biotechnologies. Solution, or one issue, I'm sure that many of you never heard about this term. Some of you know this term. I'm going to talk about synthetic biology very shortly, but you have to understand this term. Synthetic biology, it's a new paradigm. You can engineer life the way you engineer a radio, the way you engineer a car. People now can design biology, and I'm going to show you very shortly. You can redesign nature. You can correct defects. You can make it better or worse, but you can modify it. You create novel systems. In 1 minute, what is synthetic biology? Is combining engineering principle with existing biotechnology techniques. How do we do engineering today? We design, we build, we test, and we learn. If we are not happy, we go back and fix it. We want to do it in biology. The same way we design a computer, we want to design biology, and the reason there is a huge market for this, a lot of technologies are involved in synthetic biology. I'm not going to cover them all, but if you want to work in synthetic biology, it's some of computer science, physics, engineering science, chemistry, agriculture. Practically every known technology is involved, so it's a multidisciplinary field. Of course, medical sciences and life sciences. It's not a small market. Even today, if you look at companies selling products made by synthetic technology, is almost $30 billion, and this market is growing almost 20% a year. Huge investments in this field, so it's not only in the defense. I'm talking about synthetic biology at all. The biodefense market is a significant portion of it. I can give you the numbers, but it's not a negligible technology. So biodefense countermeasures, and the same advancements that create new risks also provide the tools to counter them, because synthetic biology allows very rapid response. You can design very fast. You can have medical countermeasures. You can innovate new materials and biosensors and bioactuators. And the other issue is biomanufacturing. For if you want to have an independent manufacturing base in Israel or any other country, you can switch to synthetic biology. And Professor Farron Isaacs from Yale in Thursday will give a talk, and he's doing fantastic things. You can have spiders making polymers for you, so you don't need to use other resources. You can have nature making materials for you on demand. Synthetic biology provides new tools, new methods. You need to accelerate R&D. It will shorten the time from lab to market. It's a product-oriented design using engineering concepts. It's a holistic approach tailored to the context. Also, it will reduce cost, which is always good, including non-recurring expenses. It will accelerate the whole design process of new biological materials. Just to bear in mind that today in pharmaceutics, more than 90% or large number of the new drugs, they don't reach the market. So 90% of the R&D today in the pharmaceutics is not transferred to market. So what we arrange in this conference, tomorrow afternoon, we are going to have a session dedicated to the nexus between biological, and we are going to focus on biodefense along the lines which I described in the talk today. Shimshon Belkin from the Hebrew University of Jerusalem, which he's the man that introduced me into this field, a good friend from 40 years ago. And he's one of the leaders in the world in this field of using synthetic biology or microbes that they work for you. You can ask the microbe, how do you feel? Are you aware of some explosive in the neighborhood? Tell me. So he is developing very interesting products using microbes. Asa Sittner from the IIBR will talk about when AI meets synthetic biology. I'm not going through over the whole slide, but I've added, but he can take an unknown material and tell you this is a toxic material without even knowing what is the chemistry. In the past, biology was an observation science. In the present, we build components. In the future, we'll do synthetic biology parts. And if today people expect that it will take 20 to 25 years, so we are still okay, AI will accelerate this process. AI, the use of AI will shorten the time of synthetic biology products. It will be available in, I mean, I asked Claude, the AI agent, he told me 5 to 10 years, but it makes sense. Our friends from Elbit will present their new solutions, so it's going to be an exciting session tomorrow. And this is what Farron Isaacs is going to present. I'm not going to talk about the whole slide, but he's going to talk like how to design Kevlar. You can, instead of Kevlar, which is a material which is needed for biodefense. So I would like to thank everybody in my institute, all my friends here from the institute, and Scott and Jennifer Tobin, and Liat, and Shimshon, and all the rest. And all I can say that synthetic biology is like normal biology, but cooler, and this is the future, and biodefense will depend on it. Thank you.